morning, students. Today we'll start motion and straight line with two very important concepts, and one is differential calculus. Do you know the velocity at an instant and the acceleration at an instant? Now, what exactly is differentiation and differential calculus? Basically, it's a part of mathematics, and it is going to be used in physics to measure the instant things, instant quantities. Now, just I will explain you through a graph also. Say there is a graph between two quantities, y and x, and it is like this. And you have taken 2 points, say A and B. Just understand it. It's a basic thing. I am going to explain you the fundamental points only. Okay. Now you want to check the slope of the curve. So you want to check the slope of the curve. So what you will do? You will join this and then exactly this point. So this is angle theta. And this is, say, delta y, and this is delta x. Delta is a Greek word. Delta means small. Okay? So if I ask you what is the slope of the curve, certainly tan theta is what? Delta y by delta x. It is BC by what? AC. Are you getting it? So this is the curve AB. For AB you have taken the slope. But if you see exactly, it is not precise. It is not precise. Say I want at point A. So at point A, if I want at point A, particular point A, do you know the value of delta x should be very small so that I get tangent at A only. That means if I am writing delta y by delta x, I can write dy by dx. But then for the exact and the precise value, limit delta x tends to be 0. So it will be like this. This is why we write limit delta x tends to 0. Got it or not? So you need a velocity at a particular point. Like we have written, say, what is velocity? It is dx by dt. Are you getting it or not? Remember, so limit, are you getting it? dt tends to 0, that is delta t tends to 0. So it will be written as delta x by delta t. Same way, if I ask you what is acceleration, you write it dv by dt. At a certain point, what should be the time? The time should be very less because you have been asked at a certain instant. So it will be written like this. So this is how we start with the differential calculus, that for a small point we need the that value, that slope. Here also this is, I have explained you that this is the slope of the curve and this is the general slope, but at a particular point this delta x should be 0. When delta x should be very small, then only we can calculate. So that's why we write differential calculus in this form. And now we have some very common features for this. And what are those? I am writing it in a table. Say we have a function y. So differentiation will be now dy by dx. For x to the power n, differentiation is nx n minus 1. These are the formulas. Sin x, though all are not going to be used in physics, maybe in class 12th also. Cos x. Similarly, if I ask you what is the differentiation of cos x, it is minus sin x. Then tan x. These are the formulas, sec square x. Then cot x. These are all are mathematical, minus cosec square x. Are you getting it or not? So these are the basic formulas. Even sec x, you can write it. It is the sec x, tan x. Or if someone asks cosec x, you can even write minus cosec x, cot x. And then log x, it is 1 by x. And then exponential x, it is ex. So this is y is actually the function, and first differential with respect to dx is this. So these are the common functions which are going to be used in differentiation. Okay. Say I will give you an simple example. I have, say, find differential, okay, of x cube. Now certainly dy by dx. Okay, so what I will do, I will put x cube here in place of y. What is the formula? Nx n minus 1. That means nx n minus 1. So this will come what? 3x what? Square. Again I want to find out the differentiation of this. I can find out. Similarly I can find differential of, say, someone says of y4. So what it will be? You want to find out it. So this is with respect to y. So dy of the function is y4. So what will be the following? Nx n minus 1. Very general formula is this. So 4y4 minus 1. I think you got it. This will be 4y cube. So this is how we are going to apply differential calculus in physics, somewhere where we need it. It's basically the part of mathematics. Okay. So these are the formulas which you can remember, and how to find out differentiation, why we need differentiation in what? Physics. Okay. Similarly, there are some basic what? Rules in this. Though this is a part of mathematics, I am again repeating it. But these basic rules I am going to explain you. One is that if dy dx is of cy, now c is a constant, so c will always come out, so it will be simply dy by dx. Example I am giving, say dy dx of 2x. What should be it? 2 will come out, so it will be dx, they will cancel out, it will remain 2. Okay, then we have dy dx of, say, u plus v. Now u and v both are the function, so certainly both are variables. So du by dx plus dv by dx. Similarly, we have a product rule, dy dx of, say, uv. Now u and v are the variables. So first you will take u out, you will differentiate v, dv by dx. Then you will take v out, you will differentiate du by one you are going to do. This is what we call chain rule also, it's in multiplication. Then dy dx, if it is a division, so you will first differentiate u, you will take v out, say du by dx, again the same way, but this time because it's a division, minus u, what? dv by dx upon the lower function, that is v square. And then last is, if I want to write dy by dx in another way, can I write dy by dx like dy by du into du by dx? Are you getting it? It can cut out. So these are the things which are going to follow in further calculus method. Again repeating, constant will come out if there are two variables. First will be of differentiation of du by dx, dv by dx. Then if there is a product, you know that u will come out, dv by dx, and then v du. If there is a division, then you have to write in this way. And dy by dx can be differential with respect to du, but again du get cut. So this is how we are going to apply differentiation. Are you getting it? Say I am going to I will give you an example here only, that find dy by dx, and if it is written, if y is what? E to the power x sin x. Now there are two functions, so if you put it here, e to the power x sin x, then we know that this is the rule uv. So what you will do, you will take out ex, then dy dx of sin x. Are you getting it or not? And then you will take out sin x and dy dx of ex. So Ex, what was the differentiation of sin x? I think cos x. And sin x, what was the differentiation of Ex? It was Ex only. So what is the final answer? Do you know? Ex cos x plus what? Sin x. So though I am repeating that basically this is the part of mathematics where we have to apply it in physics. So physics, you know that certainly Ex, sin x, these functions are not going to come right now, but basic is that how you differentiate any quantity. Are you getting it? So this is the thing which we are going to repeat. One again concept is there, maxima and minima. Sometime you will get maximum force, maximum acceleration, minimum acceleration. What does it mean, maxima and minima? I will just explain you. Say there is a graph, again I am repeating, there are two quantity y versus x, and say there is any graph like this. Now if I ask you where is the maxima at this point and where is the minima at this point, if I ask you draw the slope, draw the tangent, so it will be like this. For it will be like this. Say this is point A and this is point B. Now very interesting, what is the slope for this point? Tan theta is what? 0 for A and B, if you remember. That means dy by dx is what? 0. So when y is constant at a certain point, so differentiation will be what? 0. Are you getting it? If I ask you, example I am giving you, find differential of say 2. Now 2 is a constant. If I write dy dx of 2, say what it should be? 0. Because it is a, what? Only the constant. So maxima and minima means where the slope is what? Almost 0. So their differential will be 0. This is the basic concept where we write maximum force, maximum acceleration. If I say velocity is maximum, okay, what will be the acceleration? So dv by dx will be what? Do you know? 0. So these are the concepts which we are going to use in differentiation. Are you getting it? So this is differentiation. And some differentiation I can show you. Say some questions. Say differentiate. Okay. We need dy by dx as y is given, say ax cube plus bx square plus cx plus d. Now you can differentiate it. It is dy by dx of complete ax cube plus bx square plus cx plus d. You know what will happen? You open it, a will come out. Again I am repeating, you remember, constant will be out. B will come out. dy dx of what? X square. C will come out. dy dx of dx. And then dy dx of what? D. You remember A will remain here. What is x cube? Nx n minus 1. So it will be 3x square. What will be of x square? Nx n minus 1. 2x. What will be of this? It will cut out dx dx c. And what will be the differentiation of d? It's a constant, 0. So what you are getting is 3ax square plus 2bx plus c. This is how we are going to differentiate. And we are going to apply it in physics. And then I am going to give you one question of physics here. You will understand where we have to apply. See here. It is written, if the displacement of a body is given by x is equal to, say, 3t square minus 2t plus 1, where t is time, that means x is function of time. Then find velocity at t equal to 2 seconds and t equal to 1 second. Now this is exactly the question of physics, where we need what? Instantaneous velocities, and x has been given a function. Now this is where we have to use, and we all know what is the velocity. It is dx by dt. So dy dt of x, we are going to do, what is x? Put it here like this, and then you open it, dy dt, I think all of you know, 3t square minus dy dt, 2t plus dy dt of what? 1. So what it will happen? 3 will come out, this is dy dt of t square, 2 will come out, this is dt dt, and what will be the differentiation of 1? Will be 0. Do you know what will be of t square? Nx n minus 1, remember, 2t, and here it will be 2. So what is the answer? 6t minus 2. This is velocity. Velocity is 6t minus 2. This is velocity. Now put the values here. First case t2 second. Put it here. 6 into 2 minus 2. 12 minus 2 will be what? 10 meter per second. And then second case t is what? 1 second. V will be 6 into 1 minus 2. That is 6 minus 2, 4 meter per second. So I think you got it where you have to apply it. This is 10 meter per second. This is not an average velocity. This is not any other velocity, uniform velocity, but it's an instantaneous velocity. You need velocity at an instant. So how we are going to apply? Basic thing, we came to know that differentiation of a constant is 0, and if the constant is with the variable, it will come out. These are the rules already explained here, that if it's a constant, C will come out, then it will be. So these basic rules are going to be followed in what? Differentiation. Are you getting it? Now I am going to talk about another very important thing, and that is what? Integral calculus. Are you getting it? Integral calculus. You remember when I started the first chapter, I talked about two very important things, macro and micro, where we need differentiation and integration. When you integrate, we make a macroscopic things. We integrate it. So now this is going to be a part of what? Another method. Say again, I am repeating, I am drawing a curve, because all are related with the curves, the variable, the quantities. Say this is a y-axis curve, and this is like this. And you want to find out the area under the curve. Now we know that area under the VT graph is known as displacement in uniformly accelerated. Say this point is P, this point is Q. So what you will do, you will what? Join this end to this and this end to this, you draw the perpendicular lines. And then do you know what you do? That you draw parallel to y-axis and x-axis the lines. So if you draw parallel to y-axis, this will be converted like this into what? Different bars. Are you getting it? And this will be like different bars. So we have just converted into them to small bars, like like these are the bars which we have created. Just this is the basic concept I want to explain you where we are going. And we want area under this curve. Now we know that each bar is of delta x. And this end is A and this is say B. And if I say they have been distributed into n rectangular bars, okay, n rectangular bars. So I think all of you know what will be the value of delta x, B minus A upon what? N. So this will be delta x. But then you know that when you find out the area of the complete, every area will be counted here. Say this is F A, this value from here to here is a function of A. And this value is function of what? B from here. So why we want to find out the area. So we know that we will find out every bar is a rectangle. So FA into delta x, FA, like this will be the area for this. FA delta x plus then again A plus delta x into delta x plus fa plus 2 delta x. I think you are getting it, how you find the area. Every time delta x is going to add, here you can see. So this will be the area and it will go on till nth value. This is a part of, again I am repeating, mathematics, though it may not be used in physics everywhere, but some part will be used. And you just add them. Already I can explain is that it is actually the summation. You know that summation you can write? It is summation of all the functions. fxi delta xi I1 to what? N. We can write in this way. We are adding up all the area. But then exactly the area is not the curve because there are some triangles creating here, you know that. So what will happen? We have to increase n. And when we increase n, because this area is there, so when we increase n will be what? It will be almost what? Towards infinity. Again, there is a very important point. If you increase n, you will get more precise area. Do you know what will happen? Delta x will be tending towards 0. If something is infinity, then above that is 0. So can I write the area like this, that limit, again the same thing of differentiation has come, delta x tends to 0, summation what I1 to n, and it can be written like this. So how we are going to apply? Integration means we are going to integrate small thing into bigger things. What I said, to find out the area under the PQ, we have taken the rectangular bars, we have calculated its area like this, but then the extra area which is here, we have to finish it. So for that we have to increase the n so that the delta x becomes what? 0. So this is how we are going to, and this in physics is represented as, in math sorry, it is represented as integration from which end? A end to the B end, from lower limit to the upper limit, and it is what? Fx dx. So this is the function. Again repeating, how we are going to write is that I is actually what? A to B fx dx. Now if you may ask me what is this? This is the integral sign. A is what? Lower limit. And you are integrating it to what? Upper limit. B is what? Upper limit, final limit. So we are going to write it like this. Okay. And then certainly like in differentiation we are having different formula. Integration I have some formula. So integration formula also I am writing here. Integration, like in differentiation we have nx n minus 1. Here we want to find out, say integration, say there is a function and then we have to integrate it, fx dx. Okay, the first is for sin x. Sin x is just reverse, minus cos x. And then cos x, what is the integration of cos x is what? Sin x. Then sec square x is what? 10x. Are you getting it? Then we have what? The main function is that x n. Okay, now for x n, it is very interesting, x n plus 1 upon n plus 1. This will be, mostly it will be used. For 1 by x, it is log x. Are you getting it? And say for sec x 10x, it is sec x. So there are number of formulas. We are not going to write every formula here. Again I am repeating. It is just I am explaining that how the integration and differentiation has come. For integration you want to find out the area below the curve and then you can apply from lower limit to all. And main is this. See, I will give you an example. If there is a written 1 to 2, this is, you are going to integrate from 1 to 2 and it is written x square. So x square dx. What will be for this? Do you know? Apply this. Xn plus 1 upon n plus 1. So 2 plus 1 upon 2 plus 1. What is lower limit? 1, 2. So it will be x cube by 3, 1 to 2. And you know what happens? Upper limit minus lower limit. You always subtract. You need an area. You need the function complete. So 2 cube by 3 minus 1 cube by 3. Are you getting it? You have put 2 here first and then 1. and then it will be what? 8 by 3 minus 1 by 3. So this is 7 by 3. I think you got this, how to integrate. So this is how we are going to apply integration. Say I am going to apply integration. Again I am repeating. There is a question. Integration for, I am going to apply for integrate, say 2t square plus t, okay, for limits, and that is t equal to 0 to t equal to 1. Now what we know is this is the integral sign. We are going from 0 to 1. 2t square plus t is the function into what? dt, because function is written as fx dx. Remember. So this is the way we write integration function. So we can integrate it, we can separate it 0, 1. So it will be dt here, 2t square dt plus 0 to 1 t dt. And then 2 will come out, I think all of you know, t square dt. And for t dt it will be what? We are going to apply n xn to the plus 1. So t 1 plus 1 upon 1 plus 1. Are you getting it? Integral sign will go off, and for this it will be t, I am going to write t cube by 3 directly, 0 to 1, and it is now t2 by 2, 0 to 1. So upper limit minus lower limit, 1 cube by 3, lower is 0, so redirected right like this. 1 square by 2, lower is 0. So what you are getting is the answer is 2, 1 by 3 plus what? 1 by 2. So solve it, 2 by 3 plus 1 by 2. So it is 4 plus 3. It is 7 by 6. This is how we are going to get it. Again I am repeating that how to integrate the function. This is the integration which is going to be used.